If you've been following along our upgrades to the login system, you may have heard the term blind salt, and you may be wondering what that is. And then we're going to give a little bit of an explainer of what a blind salt is and how we use it to protect your information. So whenever a website stores a password, they run it through a hashing algorithm to help keep it safe. It scrambles up the information so that it can't be read and it really can't be computed backwards. And one of the ways to make it additionally secure is, instead of just hashing the password, the server will add in a salt, which is really just a long random number. And this salt makes each password hash unique, and it means that the information to compute that password hash is all on the server. So this does two things. One is it prevents what's called pre-computing. So if an attacker is going to break into a system, one of the things they can do is, before they go in and try and compromise the server, if they know what password hashing algorithm that the system is using, they'll make a table of commonly used passwords, and they can go through and they can run the hashes of all of those passwords ahead of time. And then after they've gone in and compromised the system and they get the login tables, they can just run a simple lookup. And if you have a password hash that matches the hash of one of these commonly used passwords, then now they know your password, and it speeds up the process. Another thing that it prevents is this salt makes all of the passwords unique. So whenever an attacker has compromised a server, they have this long table of password hashes and their salts, and they can go through and they can make random guesses, or they can use a dictionary attack and they can use commonly used passwords to hash that and then compare the hashes and see if they found a match. But they can only attack one user at a time because the salt value for each user is different. And what those two things do is they just create time so that the website developers can go and make improvements to their security, and the users can go in and they can change their passwords. In the system that we use, all of your password hashing is done on your computer. And that means that some salt data has to be transmitted from our server to you before you can start the login process. And that creates some very narrow vulnerabilities. The system's still very safe. Your password never leaves your computer during the registration or the login process, so you can still use it on an unsecured network. We still use very powerful hashing algorithms. It's just that there is another level of safety that we can provide you, and one way to do that is with what's called a blind salt. All right, so the blind salt process. We're going to use two mathematical properties to protect your login and protect this salt value. The first one is the discrete logarithm problem. You've probably heard me explain this in another video. It's essentially that computing something to an exponent is very easy, but if you compute something and you have to find out what this x is, which is called a discrete logarithm, the power that we raised it to get this value, that's actually very difficult. And so if we encase our numbers in exponent operations, it's very difficult for someone who observes those numbers to calculate the root values, as long as the numbers are large enough. And so the other particular feature that we're going to use is that if I have an exponent, and let's say I raise it to 2, the power of 2 equals 4, of course, I can raise it by 1 over that value, and it essentially becomes like a square root function. It's going to reverse that exponentiation. If you want to see how it works out for those people who really like in-depth math, it's the same as multiplying 2 over 1 times 1 over 2, which cancels each other out, and you just get the same number. And because of the commutative property of math, again, which I talk about in the PAKE video, the order of this doesn't really matter. And so what we're going to do to protect the salt value that we use to make your password hardened and unique is whenever you register for the website, we're going to hash your password to a number value. And for my example, I'm just going to use 2 because I want you to be able to follow along. So we're going to hash your password to 2. And we're going to create a salt value. And for this example, the salt value is going to be 3. That, of course, creates a number 8. And we're going to use that as part of your password. So we're going to put that 8 as the salt value. And we're going to hash all that. And then that's going to be the value that we use to create your verifier, which I explained in the previous video. This is the number that you use to confirm your login. So we also are going to store this value because that sort of is the seed for your blind salt. So you're going to store your verifier in this seed value. Whenever you go to log in again, we're going to hash your number to, or your password to, a number value, and we're going to raise it by a random number. In this case, we're just going to make it simple. We're going to have it be 2. And so your value comes out to 4, and we're going to send that to the server. Well, the server knows your seed value of 3, and it's going to raise 4 to the power of 3. It's going to get 64, and it's going to transmit it back to here. Well, our random value was 2, and so now we have 64, and if we raise it by 1 over 2, it's essentially a square root, and the square root of 64 is 8. And if you will remember, that is the blind seed value that we started with. And so now we have this, we pair it with your password, and then we hash it, and then we run all the PAKE processes that I described in previous videos. And it's a fairly simple upgrade to add to a PAKE system, and it just ensures that that salt value isn't leaked out in any way, and it really upgrades the security to a level where any attacker has no better chance than random guessing to compute a password hash, because not only do they have to run a value through our hashing algorithm, they also have to compute these blind salt values, and then they have to go through and they have to raise it to an exponent to get a verifier value. It just makes it much more complex, and it makes your password much more secure.